Hello, good morning, good evening, or good afternoon, everyone, depending on where you are. Welcome and thank you for joining me today. Hi, my name is Fitz, and today's lecture is going to be on data locality and keeping things local. So let's get to it. So the question is, when was the last time you thought about your app's data? And I mean like really thought about it. Where did it come from? What was its journey like going from there to here? Where is here exactly? And for that matter, where was there? Pretty much all of our apps use data in some way, whether it's some photos or other media, product information, or creating data to be rendered and drawn in interesting and colorful ways. Without some kind of information or data, an app would be somewhat uninformed. And often when data is mentioned, the first question that comes up is, what about state? And it's an important question. It doesn't take very far into your Flutter journey before you're converting a stateless widget into a stateful one, and wondering what that state object is right before you tumble down the winding path that is notifiers, blocks, and state management. Like data, without state, an app wouldn't be very interesting or useful. Knowing how to manage it, how it flows through your app, and when to just use set state versus a value notifier versus package provider, these are all important and useful topics to pursue. Those fancy graphics wouldn't draw themselves without state. But this is not that talk. And in fact, for the entire rest of the talk, you won't hear me use this word again. Because this is a talk about data and about managing your app's relationship with data. And so when you're looking at building an app, and it doesn't matter what framework you're using, there are a number of questions to consider when thinking about data. First is, how much do you need? And by that I mean how much is critical to your app versus some things are okay to wait for. Second, how stable or ephemeral is your data? And by that I mean, is it going to be viewed or accessed repeatedly? Then maybe it's stable. Or is it only going to be accessed once and probably never again? We'll call that ephemeral data. And third, what is the true origin of your data? Where does it come from? Is it generated locally by someone actually typing in some data? Is it generated by other users? Maybe other people are taking photos. Or is it stored or generated by your own backend? And finally, where is your data going to be stored? And for that, it's easy to say, let's just go to the cloud. After all, with the cloud, our app will have data everywhere, at all times, no matter what. Until we don't have that. Since our devices are out and about on the internet, sometimes we have connectivity problems, and sometimes things just run a little bit slower than we'd like. And so on that last point, I'm curious how long it takes for us to get data from the cloud. And when you ask the internet that question, how long does it take to get data from the cloud? There are a lot of disagreements. What's the important metric? Are we measuring latency or bandwidth? Are we measuring something else? How do we measure that thing? Where do we measure it from? What services do we use? What kind of data do we use? How is that data interpreted, parsed, or used on the client side? And generally, what assumptions are we assuming about the system? There's all kinds of disagreements, and every benchmark you look at is going to be slightly different in some way. And so I ran my own. I went to the cloud. I went and pinged google.com, cloud.google.com, and I was attempting to see how fast I could get from here to there. And the results were encouraging. On average, depending on if I was wired or wireless, I was getting less than 20 milliseconds of ping. And that's great. Generally, we're looking for response times less than 100 milliseconds or so. And so less than 20 seconds, awesome. Except that's ping. And it's also highly variable. On the real internet, when we're looking around the world, depending on where you are, where you're going, and how the weather looks like today, you can get pings anywhere from less than 10 milliseconds up to well over 300 milliseconds. And so already we've blown by our recommendation of 100 milliseconds for good response time. But even then, it's still not real data, because it's still just taking a packet a random network packet and sending it on the network and seeing how long it takes to come back. It's not actual application data. Because when we're looking at actual application data, say we're going from our phone to the actual cloud, there's a few more round trips involved here. We have to ask for data, we have to authenticate, we have to go and find the data, the service has to go and find the data. It takes a little bit more time to actually retrieve all of our data. And so when you look out in the wide world of cloud data benchmarks, they're all over the place. You can see anywhere from tens or hundreds of milliseconds up to potentially thousands of milliseconds, depending on the service. So I'm going to split the difference and say 1 second. That we have 1 second where we'll be retrieving cloud data. So what can we do in 1 second? Well, in 1 second, I can download about 30 megabytes on my home internet. It's decent. Or I could read about 500 megabytes from a standard 2.5-inch solid-state drive. It's already quite a bit better. That's a lot of data in 1 second. Or I could read 96 gigabytes from my CPU's L1 cache. And of course, that one has to be fast because the CPU itself can process about 120 gigabytes per second, depending on your CPU and depending on how you calculate it. And so we can do a lot in 1 second, depending on what we're looking at. The solid-state drive already is way faster than the internet, and then when we're looking at actually processing data locally, it's much, much faster. And just for fun, in that same second, the current fastest supercomputer in the world, Japan's supercomputer Fugaku at the Riken Center for Computational Science, has a peak computation rate of about half an exaflop. That's 17 billion times faster than my home internet trying to download something from the cloud. So we can do a lot in 1 second. So what am I going to do with 1 second here? I'm going to go and fetch a single flag. 1 bit, just true or false, whether or not we should turn dark mode on in our app. And so you can see this is the example app that we'll be working with. And the material app is there waiting for a that dark flag to come back. I'm using provider, and it has a dark notifier, which is notifying me of if I should be in dark mode or not. And this entire app is waiting for that flag to be true or false. We're just waiting for the existence of that flag. And you can see in this animation that after about a second or so, 0.959 seconds, we get that flag and we can actually start rendering things. And of course, we see the images are running slowly as well. We'll get to that in a moment. And so this is the app that we'll be working with. And for this first one, I want to go back to our questions about data. And our first question, how much data do we need? And I'll pose a follow-up question to this, which is, how long does that 1 second compare to how much data you're retrieving? For example, in this app, I am blocking the entire app on loading that single bit, that one flag, that one true-false flag. And it's super important. We need it because we don't want to have this weird bit that's happening where it starts off in light mode and then flashes over to dark mode really quickly. It's not a great user experience. We'd like it to be available immediately. And so that bit is super important. But compared to what we could be doing in a second, we could be conceivably retrieving millions or billions of bits. So that's millions or billions of times more data than we are retrieving. And so for a 1 bit, that starts to feel like a little bit of an eternity. And so we're going to change that. We're going to not pull it from the network, not pull it from the internet, but instead use a package called shared preferences. And so we're going to pop over to the code here. Hi. And actually play around with the code. So you can see here on the right, I have my app, and of course I can restart it, and we'll see in my backend logs that we got the dark mode, and it took about a a little less than a second for that dark mode to appear. And it's loading. The images take a while to load. And you see up here, I've got my run up is creating the dark notifier, and same as in the slides, the dark notifier is here waiting for is dark. So let's go and look at that dark notifier thing. We're storing that in its own data class to just be able to keep a handle on it. And here, when we create it, we're starting with this method of loading the dark mode preference. And that is using the HTTP client and calling out to our backend host to get our preferences, decoding that JSON, and then parsing it out before notifying all of our listeners. Okay. So that part, this is the part that's running slowly because, well, you can see that our backend is taking almost a second to actually render this. So I'm going to replace all of this with shared preferences. And shared preferences is just a local storage option that is based on key value pairs, where I can have some sort of name and it'll just return me a value. That package stores things on the local disk for whatever system this is. So it'll make a different decision depending on if we're on Android versus iOS versus desktop. It'll make it'll figure out where the proper place to store this is. So this is the part that's running slow. I'm going to delete it, and we're going to use shared preferences instead. Note that I've already imported this package, and I've already added it to my pubspec.yaml to get this imported. Note that when I first did this, I had to re-clean and recreate the Flutter project in order to, in debug, to get that to auto-create things. And so we've kind of already got this set up because it's an asynchronous function that before was using HTTP client to actually get our data. And we need that to still be async as well in shared preferences. Because if you remember that earlier graph where that internet speed, 30 megabytes download, the solid state drive was at 500 megabytes, and it was a huge difference. But then there was a way bigger difference when we were looking at CPU processing speed. And so when we're looking at what is the app doing, well, even when we're retrieving something from our hard drive, it's still going to feel like an eternity to the CPU. So we need to await for it. We need to have that in an async. And what we're going to await at first is the shared... we're going to get the instance of the shared preference. And then, because this returns a future, so we can chain it with .then, that gives us a preferences object. And within that object, here's where we can just access our key and value. And so what we're going to do, we're going to say we have a dark pref, and that's just going to be it's a Boolean, and so we can use our prefs object and get a Boolean. And we can call this whatever. It's just an arbitrary string that we can use to identify our value. And I'm going to call it is dark. Just nice and short. And then when we first do this, there's no is dark value. So if it's null, we'll go false. If it's not dark mode, we'll assume light mode is fine. Okay, but you'll notice up here I had this current prefs data class to use, and so I'm going to do is current prefs is now going to be a new one of this data class, and I'll keep my promise from earlier and not say the full name of this class. And this is going to be, what did I call it? Dark pref. Okay, that's all we really need. That's all we need to start using our shared preference. I imported the package, I got the instance within an async class, and then I pull the exact key that I want and save it for later. And I'm gonna hot restart this so we get it from from cold, notice that in my console here, we have a bunch of, we're waiting for these files to appear, almost as if they're arbitrarily slow. But we weren't waiting for the dark mode preference. And of course, we're still light too, because we set it as false. So I'm going to refresh again so we can see that happen. And our list appears almost immediately. And there's a slight pause there that's hard to see. But there is a slight pause there. And that's just because it's pulling from the disk, which still has to wait a little bit. Okay, the other thing that's here is we have this button that I can use to switch between light mode and dark mode, and I just click that button. And right now, when that's clicked, you can see in the console logs that it's doing the same call to the backend to try to save this this preference. But right now, that's not necessarily necessary. And so instead of this HTTP client, I would like to save this preference to this shared pref as well. So again, I'm going to await my shared preference get instance, and then I have my prefs object. And within that, all I need to do is prefs dot set boolean instead, and we need to make sure we use the same key. I should really pull this out into a constant, but for now I'm just going to put that there. And then we're going to set it to current prefs dot dark mode. And so that's setting to what it currently has, and just to make sure that it is actually flipping it. Because you'll notice when I clicked on it, it happened immediately. When we go into our app's code, we have our scaffold and our app bar as you'd expect. We have our body, and our floating action button is this thing. And sure enough, we are setting our dark mode to not is dark. So we're flipping that bit when the button is pressed. So we can just go and set it there like that. And that's all we need. We don't have to change it back. We don't have to return it because we've already done that. All right, so now I'm going to refresh again. And what I'm expecting to see is no new messages in my backend log about sending or receiving a dark mode preference. We'll wait for that to load, and I'll click the button, and we'll flip it back and forth. And sure enough, no backend message. So great, now our shared preference thing is actually storing our dark mode preference, and you can see all the cloud images get cycled out to inverted images. That's just what I decided to do for the dark mode. So that's our shared preference. We've removed that that 1 second delay in the beginning of our app, and moved all of that data locally. So now we have access to it basically immediately. The second thing I want to tackle here is these images. Like, I scroll up and down, and there's just these blank spaces where images should be, and they take a while to load. Sometimes they take long enough that we have to put in a little spinner to indicate that it's loading. This isn't a great experience. Like, they take forever to load, almost as if we are arbitrarily waiting for them to reload. So that's the next thing that I want to tackle. So we've handled our shared preferences. Great. And those those images are simply using image.network. And when you look at the image.network documentation, it has this bit, like this one line sentence that says all network images are cached regardless of the HTTP headers. Now that's curious because, and you can see it here in this animation as well, that our images don't appear to be caching. And so it begs the question of, like, what's going on there? Are our images too big? Are our headers not set properly? But that shouldn't matter because the documentation says the headers don't matter. And so the question is, what's going on here? So let's dive into it. Let's look at what's going on. First, the image.network widget is actually really simple. It just hands everything off to something called the network image. network image is also rather simple. It hands everything off to the implementation of a image provider network image. Okay, that one fetches the image and manages some of the image bytes using the multi-frame image stream completer, which is really just an implementation of the image stream completer. And throughout all of this, there's an image stream class that's just kind of a little bit of everywhere. And that thing is the thing that actually has the bits and bytes for our image. And so if it has our bytes for the image, that's probably the one that is caching it. And in fact, you can find in its documentation this line about how the image cache will consider an image to be live until its listener count drops to 0. Okay, so that's useful knowledge. It says that the cache will only cache something or keep something around if it thinks it's in use. That's good to know. And that last part of the sentence is really just saying that when we first create it, there's probably no listeners because there's that brief period between creating it and attaching a listener. When we first create it, it's okay to have 0 listeners. We'll keep it around because we assume that at least one listener will be added later. But if it ever drops back down to 0, that's when we say, this thing is probably not used. We can consider it done. We can consider it available to be recycled and get that memory back. So when we have this list view where those list items are being disposed of rather rapidly, it's as if someone set the cache extent to 0. Those images routinely have to be recycled, and they're routinely marked as being able to be disposed and destroyed of. So that might be fine for a lot of cases. Maybe our clouds it's okay for them to take a little bit to arrive. That's okay. But maybe there are other cases where it's less okay, where we actually want those images to persist and be around. So for example, a few examples, maybe we have a book library, and I've already got the book on my device, and it'd be really nice if I had the cover image already available. Likewise, maybe I'm a teacher and I have my roster or seating chart, and sometimes class time gets a little hectic, and it'd be really nice to have that roster load as fast as possible and not have something else that I have to wait for or handle. And then, of course, we could have audio-video media of some kind, home videos, personal photos, offline music, podcasts, things like that. And of course, those ought to be local, so I can play them offline. And so this goes into our second question about data. How stable is it? That is, how often will you need to be accessing the individual things, like our images? So let's suppose that these cloud images, I'll go back one slide, these cloud images that are taking a while to load, let's suppose that I would like them to not load, that they're going to be relatively stable, and I would like those to stay around. Let's try caching those to disk as well. We did that with shared preference because our internet speed for that one single bit was taking way too long. But even with relatively larger images, it's still nice to keep those around. That SSD, that shared, that solid state drive transfer rate was much faster than the internet, no matter how much data we were trying to get. And so let's cache things to the disk. Now, I could write my own cache. That is an option that I could do. But instead, there are packages that can help us do this for us. So I'll head back to the code. Hi. And I've got my dark notifier open. I'm going to switch back to main. And when we scroll down, here's our image.network. It's just pulling from the image URL of wherever this image URL is coming from. It's initialized as part of a cloud image creator thing. That all's down here. I'll share the code later. And if it's not, if it is loading, we'll pop a circular progress indicator on the screen. Otherwise, will just return the image. So I have a helpful note here to myself. We're going to switch that out for a package called cached network image. You look at pubsec.animal. I already have this imported here. And I already have it imported up top, a cached network image. And this package provides a widget, which is pretty simple. It's really similar to our image.network. And so I'm going to just replace this. That goes away. And so instead of our image.network, I'm going to do a cached network image. And our autocomplete is helpfully saying that I need our image URL. Hot reload is helpfully telling me that I have problems there. So this is all you really need. I've got my cached network image, and I'm passing it an image URL. You can see that it does some helpful things for us automatically, like it's fading in those images, and there's no loading image, which is probably fine. We might be able to override that. And sure enough, those seem to be loading pretty nicely. And in fact, we can verify whether or not it's actually caching them. We can go and find the files for this device. I'll go to my terminal here and I'll check out Flutter devices. It'll show me that the iOS device that I'm running on has the identifier that you see here in the terminal, this long UUID, that's 2B3 something or other. And that's where I am. And I'm going to just do a find through there and find all of the JPEG files here. So we've got this directory lib cached image data. Great, we have a place to go and find our data. So note, so I'm in that directory now, and our images are loading pretty well, barring any, my laptop is running slowly trying to do all of the streaming, so any delay right now is because of my laptop. So we have all these images, and I'm just going to delete them all. And now, when we go back into it, notice that my backend has started logging these again. And these are taking a little bit longer than with the cached image to appear. And most of them are back. And we go back up. Our backend has logged more things. I can clear that to show that now that we've scrolled through the entire list, there should be no more calls to the backend. Notice we're not waiting for any of those anymore. But again, if I delete them all and then redo that, sure enough, I have to go and get new images. So this cached network image, sure enough, is saving these files to disk and is getting us a lot of benefit. It's speeding things up quite substantially. And there's more that we can do with cached network image. For example, we could put in a placeholder, like maybe I wanted a circular progress indicator here as well. And what is the recommendation here? We need it to be a builder. Okay. So we'll make it a builder, which takes just a context. Which returns a widget. Oh, sorry, that requires 2 parameters, which I only need the first one. Okay, this is why we refer to notes. And that looks kind of funky because it's taking up the entire space that we have there, and so we can just wrap this with a center and get just the small circular progress indicator loading. Great, so that's a little bit better. We can also do things with this, like we can have our fade in duration be, we can set that to 0 if we wanted to have our images appear rather than fading in, so you can see that they're popping in like that. We can also have the fade out duration, which would be for when that placeholder circular progress indicator is going away. You see, it's really hard, might be hard to see on the stream, but it's slowly fading out on top of the image. Maybe we don't want that. Maybe we do, maybe we don't. But when we do our fade out duration, we can override that to have it pop out the circular progress indicator as well. So now that disappears immediately too. Great. Okay. So that's our cache network image, and that was also really super simple to implement, to pull those network files in, and make sure that when we are reloading these things that they stay around. I'll note that this does take disk space, so if you're on a device that has limited disk space, it can take things up, and there's ways to override this and make sure that you're only using certain amounts of data. So we can talk about how much data it takes up in memory, and provide our own custom cache manager. This is using a package called the Flutter cache manager to make that happen. But that's it. We've now got our images loading locally. Awesome. And so we're almost done. We've got just a couple things left to talk about. And in particular, there's this third question that I haven't addressed yet. Where is your data coming from? What is the origin of your data? How is that data created? And so for that, I want to run out to the whiteboard. So here, I've got my whiteboard. And let's suppose that I have this little bit of app. And in this part of the app, this is the cloudy recorder. I have this table-like thing. I've got these columns and I've got these rows. And so I could certainly put some data in here. So maybe dash is a type cloud of cirrus. And maybe I last saw it today. And what I'm going to do with this is I'm going to add these shared buttons. I'm also using another package here, so this is just going to be a Boolean to add. And what I'm going to do with that, this save button, is going to save out to a database, because this table kind of looks like a database table. So when I click on that, this is going to call out to a package called SQFlite. And this package is a package that utilizes the SQLite standard for just having a local file-based database. So we don't have to have a network call. We don't have to have we don't have to call out to another process. We don't have to call out to a cloud service. This is all stored locally still. So SQFlite takes it out and stores it to a file-based database. There's my little file-based database symbol. And so because this looks a whole lot like a table, we're just going to create a table. So within this, when this is first created, what we're going to do is, and I'll make sure I'm not on the edge of the screen. What we're first going to do is create table. And that create table statement is going to look a heck of a lot like our table up here, where we have our name, a type, and the last seen columns. And of course, once we have that, to get all of our data back, we're just going to do a simple select star. And of course, depending on what your data looks like and how you're using the data, you might want to do this a little bit differently. But that's going to be the next thing that we look at doing. And for that, this is what we're going to call structured data. So again, we're saving our data to our local storage, to our hard disk, our solid state disks. But this time, instead of having it be files, just blobs of data like images are, this time we're going to do some structured data. Okay, so we'll go back out to the code. Hi. We'll click on the drawer. So there's actually some things here, and you'll notice that my dark mode actually added some transparency. I don't know, seemed fun. And we go into our cloudy input recorder. So we have this cloud recorder. And actually for this, I'm going to move it back to light mode, which we'll have to refresh the images for. But I've got some data here, and we look at the spreadsheet. This is using a package called editable. And this is a package that provides a grid that kind of looks like a spreadsheet. You can click into it and edit these things. So I can with my keyboard edit those. I can hit enter to finish it. And I've got these save buttons already, but let's look at the code and see what's happening. So here we have that object, this object, and within that, I've again got a future that I'm waiting for data, because again, remember that graph of the things going up and down. Our solid state disk is fast. It's much faster than the network, but it's still really slow in comparison to our CPU. So we still have to wait for things. And here we're saying, for now, I'm just saying that I've got some placeholder roles that are being returned immediately. This is just this flat list of map objects. And once those are available, if they're not available, sure, let's use a progress indicator and get something there. This is available immediately, so it never shows up. We'll remap it onto just a dynamic list to send it over to editable. So this is also a relatively simple widget, to use. You provide it what columns you have, so we'll go up and look at that. Like our database, we have some name, type, and last seen columns that we're using. And our rows are just those placeholder rows, those flat maps that we have. And that's pretty much it. I've got my save icon already on, so I can click save when we're ready to do that. Right now it doesn't do anything, so we'll get to that. We'll fix that. First thing here is this. We've got our placeholder rows. That's just stored already in memory, but I would really like these to be saved to a database. And the rationale for this is that maybe this is a mechanism for recording information and observations about clouds. Great. The best way to view a cloud and see a cloud is to be in the cloud. And maybe I'm in a tiny little prop plane and I don't have any internet. And so I can't use a cloud-based service, because I don't have any internet. So I need it to be stored locally. And so I've already done a lot of the work here. I have this data provider class down here at the bottom, and this is utilizing a database, which is coming from the SQFlite package. And sure enough, here, when we open the database, we create the table like we saw on the whiteboard with our name, type, and last seen data. Cool. Okay. So I've already initialized it up here in this object as well. And what we're going to do, our future, is just going to be to get all of our data. And so when we pop into that returns a future list of clouds, and it's just doing a query, getting all of these fields from this database. And then it's doing some mapping to translate it into something to reasonable objects and returning them out. Okay, so let's see what's in our database. Yep. We'll refresh because we made some changes to persistent data. We'll go there. Okay, there's nothing in my database. That's cool. So like when we checked for our image files, we can also do the same thing for this database file. I did claim that it's stored in a file-based database format, and so let's verify that. So I've searched through this device for the clouds.db, and I can just use the SQLite command line to go in there, and we'll check our schema to make sure that, sure enough, yep, there's our create table for the clouds. And I can also verify that there's nothing in there by selecting star from that. Sure, there's nothing there. So next thing we have to do is to actually edit this and provide some data here. So what we can do is we'll add a row here. This is me. Maybe I'm a Stratus cloud, and maybe we last saw me today. Right now, I click the save button. Nothing happens because our on row saved is not doing anything at all. Let's make it do something. And so what I want to have it do is this editable package gives us the row with all the data unless there's no edits made. And what it does is say, it just returns us a string that says no edit. I want to say if it doesn't equal that, then I want to actually insert this row into the database. So I have an insert function already written. That row is just a dynamic map of keys to values. So I'm going to take that from a map and translate it there. Okay, let's give this a shot. I'm going to do a hot restart just to make sure we're running from a clean clean bill, and go there. We'll add our new row. We'll maybe this one will have it be dash, which is of type cirrus, which we last saw today. Hooray! Now we save. Okay, maybe we'll save it again. We'll see what happens. Oops. There we go. Now we have two rows. Now, granted, I'm not doing some ID checks to make sure we're not getting duplicates, so that's a bug that we will have to solve in the future. But I do have that data in this database now. So if I refresh this, we'll do a hot restart again to make sure I'm pulling in the new data. We'll go back to our cloudy data input, and sure enough, there are the two rows that we've saved. So we'll need to update this to check for the IDs, but that's going to be for another time. We now have our data stored in a structured database. So that's our structured data, and that covers our three questions. So let's review for a second. We started this tour with saying, where should my data be stored? That was our fourth question, and we started there and we worked our way backwards. And the answer really is, it depends. So how critical is your data to your app? And how long does network retrieval, it's getting something from the internet, really feel for that data? Does it feel like an eternity? Okay, that's a consideration. And then, how stable or ephemeral is your data? Is it going to be viewed just once? In that case, ephemeral, and maybe it's okay for it to be taking a little bit to load. Or is it going to be viewed multiple times, like that audiobook cover that I mentioned? In that case, maybe consider locally, so we can rapidly retrieve it again and again. And finally, where is the source of your data? If you are observing clouds and have no internet and need to record and save data, definitely store it in a structured format like a SQLite database. Just also don't forget about the cloud too, because once you do have that internet access back, once you do have that ability to await things and send them out via Future or an isolate to get things saved to the cloud so you can sync them back up again depending on where you are, that is also extremely useful. So that brings us to the end of my talk today. I'm going to hang out for just a little bit and answer any questions that we see coming through the comments. But otherwise, thank you so much for being with me. So I've got the comments open. I'm assuming there's probably a little bit of a lag, so I'll hang out and wait to see if there's any questions. I see a note about uploading the app to GitHub. Yes, I will. You're welcome for the opportunity. Does SQF-Lite support desktop platforms? Yeah, I hadn't tried it on the desktop. I did have this app running on the desktop, but I do know that the SQF-Lite package calls out to the underlying SQLite implementation, and SQLite is available pretty much everywhere. So I haven't personally tested it yet, but I'm quite certain that it very likely works. There's a lot of qualifiers in there, but yes, it should work there as well. There's another question here. How to save the data of the settings of the app, and is there a specific package for that, and how to make a backup for settings data? Yeah, I think for that, it depends on what your settings look like. So in the app that I was using here, my settings were just simple key values. Is dark, true or false, and those are my settings. You could certainly just keep using shared preferences for that. It's just a big old key value store. And you can save whatever you want there. If it can be represented as just some keys and values, some strings to some other data type, then you can use shared preferences. From there, shared preferences only stores it locally on your device, and so you'll need some method to sync it to the cloud if you want to have it stored in the cloud. And there's lots of services. Firebase is a great one. The real-time database allows for that key value type storage, and that library has some nice features for getting things synced back and forth. Hopefully that kind of answered your question a little bit. Next question is, how do I get the network performance on the terminal? The milliseconds thing of how long it took to get the response. So we'll come back to the code. Hi. And so I assume you're referencing this line here where we're saying we're waiting somewhere, up to 5,000 milliseconds to get our file. There's nothing fancy here. This is a backend written in Node.js using Express. And when I get down into when I'm actually getting a specific file, I generate a random number, and then I console log that number out before I sleep, before I wait for that amount of time. Nothing fancy. This is just for demonstration purposes to artificially make sure that these things are taking a long time to load, and it's just running locally on my laptop. That said, if you wanted to actually see some of the real performance, I definitely recommend opening up the Dart DevTools, which has the network performance tool. And of course, I have things very zoomed, so it's going to take up a lot of space. The network performance tab on the Dart DevTools will also show you things like how long this took. So here are all of my requests, and how much was actually read or not for these requests. So this is another good tool to check out there. What is the name of the software or program that you use to save your data? I'm not quite sure what you're asking there. There's a lot of different tools that I'm using here. I'm using Visual Studio Code to write the code. I'm using, depending on whether we're saving the structured data or just an image or the shared preferences, that changes what package is being used. So the image is saved on the disk with a package called cached network image, and the structured data is saved with a package called SQFlite, and the key value shared preferences, so the dark mode is stored with something called the shared preferences package. Is there any article or link for the command to access the database inside my phone like I did? I don't know if there is. Maybe that's a good... I'll make a note to see if we can find one and maybe create one. How about that? I don't know if one exists already. I kind of poked around myself and found it, but let's see if we can write an article. I'll make a note on my whiteboard. At very least, there is a package of the week video on the flutter.dev YouTube channel that goes over SQFlite and does it really quickly. I don't think it goes into how to access it specifically from a phone like this, but there is an SQFlite package of the week video. Is there a link for the code? You know what? How about while I'm not sharing my screen, let's see if I can quickly create how fast can I create a new repository? That's the question. We're pushing up to the internet. Remember that internet upload speed is a lot slower than everything else. Here we go, and then check this out. There you go. There's our link to the code. It's pushed up there, and I think it's probably missing the latest changes. And now that repository is on GitHub with all of the changes that we've made here today. There you go, real-time GitHub uploading. And I was asked to end at 5 minutes before the hour, so that's going to be it for For me, thank you so much for being with me. Thank you so much for your great questions, and we will see you next time. Bye.